We are on our last set of statistics notes, which is margin of error. And this is important in day-to-day life. If you watch any news, read things on Facebook, you will see results of polls. And we have to interpret what the small print on the TV screen reads, which is a margin of error. So let's take a look at this first situation. Alice and Caleb are running for mayor. We have conducted a recent poll. Now, are we going to survey everyone in Smithville? Probably not. This is a sample. And so based off our sample, 48% of the voters would vote for Alice and 46 would vote for Caleb. So 48 for Alice and 46 for Caleb. But then we notice that we have a margin of error of 3%. The remaining 6% are either voting for another candidate or undecided. The local news reporter said that Alice is going to win, or that Alice was in the lead. Do you agree with the news reporter? Well, if you missed this key statement about margin of error, you're going to say, yeah, I agree with the news reporter. Alice is ahead. However, what does margin of error mean? When we collect a sample, since we are not asking the population, we give ourselves room for error. We are making a prediction about the population, the entire city, based on our sample. And so since we are using a sample, we leave ourselves some room, like I said, for error. So actually, while our sample found 48% would vote for Alice, our interval that we are predicting would be 48 plus 3 to 48 minus 3. So we are actually making a prediction that the true proportion to vote for Alice would be between 45% and 52%. Again, it's a prediction. That may not be what happens, but that's our prediction. So for Caleb, he also has a margin of error for 3%. So actually, our results are showing that we may have up to 49% vote for Caleb, or we could have down to 43% vote for Caleb. So, is Alice in the lead? Well, not necessarily. I mean, we could, based off our sample, 49% could vote for Caleb, and then that would put Alice behind him. So when someone takes a poll or a survey, it's usually taken from a sample of the population. When we gather our data wisely, it can represent the population of a whole. However, even a wisely chosen sample, the result can still vary from the entire population, and so that's why we use margin of error. So if the margin of error is 3%, and I just realized that I added 3 wrong, 48 plus 3 is not 52. It's 51. That's why you need you guys to catch my mistakes. So let's go back to where I was. So if the margin of error is 3%, what that actually means is that we have anywhere from 51% to 45% that may vote for Alice. And so what does this tell us? Well, it tells us that Caleb may actually be in the lead. Based off a sample, statisticians can create margin of errors. Our margin of error in this problem is plus or minus 3%. And what we have created up above is called a confidence interval. A confidence interval. So we created a confidence interval for Alice. And so if we wanted to write a conclusion, here's what this means. The true proportion of people voting for Alice may be in between 45% and 51%. Notice we didn't say it definitely is in that interval. We might have a bad sample. That could happen. So this is just a prediction. So let's look at another situation. Let's say you survey 10 DB students about if they're going to drive a car to school next fall. 6 say yes. How confident would we be that the true proportion is 60%? Then we survey 100 students, and 42% of those say yes. Do you think this would be closer to the actual percentage? It probably would, because we have sampled more students. Assuming that our data collection methods were good methods, and we'll talk more about that in a second. So the larger the sample size, the closer the sample mean is to the actual results, the population mean. That's important. The bigger the sample size, the better our estimation is. So let's create a confidence interval. You want to know the proportion of students who like the school's food. You survey 100 students and find 36 to enjoy the food. You calculated your margin of error to be 10%. What would the confidence interval be? So we take 36% and we add 10 to it and we subtract 10 from it. So we are estimating that anywhere from 26 to 46% of the population would like the school food. Now again, that's a sample, but that's our prediction. And places might want those predictions because they may decide on how much food to make on a given school day, funding for school food, and different things like that. Now, when we are collecting these surveys, we want our sampling method to represent the population. So let's say we're back to asking 100 people about the school's food, and we want to survey, and we have different ways we can collect our data. Let's talk about what's a good way of collecting our data. So number one, you place every student at DB's name in a hat and draw out 100 names. Would that be a good way to collect 100 students? Yes. Why would that be a good way? Well, first off, everyone has a chance of being selected. Next, it is completely random. You will get a variety. You'll get seniors, juniors, sophomores, freshmen. You'll get boys, you'll get girls. It's completely random. Number two, you survey 100 students in line at the cafeteria. Would this be a good way to collect the data? No. This method is considered bias. Well, who are you asking? You're asking people that's already in line in the cafeteria. They're in line at the cafeteria. They probably like the school food or they forgot their lunch. But it's biased. You randomly select 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. Is this a good way to collect data? Yes. You are ensuring that you have a variety of grade levels in your data. You post a Facebook survey and have people respond. Not a good way to collect data. This is called a voluntary response bias. Who's going to respond to your survey? Only people who feel passionate one way or the other. Same thing with calling into a radio station, answering a question online. Any poll where it's just made available to anyone is going to result in bias. You select every person that every fifth person that walks into the front office. That's probably a pretty decent way. I mean, you're going to get a variety of people. and you're doing every fifth person, so you have a pattern down. So you are going to get every grade level, boys and girls, students involved in different activities. Now, yes, we know that not every student walks through the front office, and so there may be some bias introduced, but you are probably going to get a variety of people. So in order to reduce bias, you want methods that are random. You want to select your individuals randomly. So this is our last set of probability notes and statistics notes. You can certainly re-watch any of them. Make sure you check our pacing guide that I have given you to know what's due when.